Cambridge Chemistry channel by Sarvataman. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will solve chemistry paper 2, May June 2020. Let's start. Gallium is an element in group 13. A sample of gallium is analyzed using a mass spectrometer. The mass spectrum produced is shown. So on y-axis this is relative abundance, and on x-axis the mass of isotopes are given. So there are two isotopes and relative abundance of 69 is 60.11 and 71 gallium is 39.89%. Question: explain what is meant by the term relative atomic mass. Relative atomic mass is the average mass of atoms. It is the average mass of atoms of an element relative to 1/12 of C12 isotopes. Calculate the relative atomic mass of gallium in this sample. Give your answer to 4 significant figures. Show your working. The relative atomic mass of gallium is equal to, so there are two isotopes given in the spectrometer, in the mass spectrometer, that is 69 into 60.11 plus 71 into 39.89. divided by 100, which is equal to 69.79. So the answer is 69.79. So the 4 significant figures. Complete the table which describes the gaseous atom of gallium. So atomic mass of gallium is nucleon number is 71. And gallium is 7131. So the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2 and 4p1. So the total number of the total number of electrons in the lowest energy level, that is the lowest energy level, the electrons are 2, and the type of orbital which contains electrons in the highest energy, this is the highest energy level, p orbitals. Next question is, when gallium is heated in excess, chlorine gallium trichloride is made. Draw the shape of the gallium trichloride. Gallium is present in group 3. So this is gallium. Gallium has 3 electrons in valence shell. Fluorine. The bonding angle is, the shape is trigonal planar. The bonding angle is 120. Gallium oxide and aluminum oxide react in the same way with HCl and with sodium hydroxide. Suggest the equation for the reaction between Ga2O3 and HCl. O3 when react with HCl to form gallium. Like aluminum oxide, it is amphoteric oxide, so it reacts with HCl as well as sodium hydroxide. Suggest an equation for the reaction between gallium oxide and sodium hydroxide. Ga2O3 plus sodium hydroxide to form NaGaOH tetrahydroxide plus water. And the formula name is gallium aluminate. Next question is nitric acid can be made in a 3-stage process. Ammonia is oxidized by oxygen from the air to form nitrogen monoxide and water. This reaction is carried out at 10 to 13 atmosphere pressure and 900 degrees centigrade in the presence of a platinum catalyst. Nitrogen monoxide react with more oxygen to form nitrogen dioxide. This is minus 114 kilojoule per mole. Nitrogen dioxide reacts with water to make nitric acid and nitrogen monoxide. Write an equation to show the reaction occurring in stage 1. Reaction occurring: ammonia is oxidized by oxygen to form from the air to form nitrogen monoxide. Ammonia Draw dot and cross diagram to show the arrangement of outer electrons in molecule of ammonia. In boxes given the oxidation number of nitrogen in the nitrogen containing species for the reaction in stage 3. It is 2 to the 4 nitrogen dioxide, 2 to the 4 minus and plus 4. NO2, like this is X, plus 2 oxygen atom charge is minus 2 is equal to 0, or X is minus 4 is equal to 0, X is equal to plus 4. Similarly, HNO3 is equal to 0, x plus 1 plus 3 minus 2 is equal to 0, 1 plus x minus 6 is equal to 0, x is equal to 5 plus 5, and similarly NO is equal to 0, x plus minus 2 is equal to 0, x is equal to plus 2. So this is oxidation state of nitrogen monoxide. Explain why the reaction in stage 3 is described as disproportionation reaction. Include reference to transfer of electron in your answer. Nitrogen is oxidized by losing electrons from NO2 to HNO3, like plus 4 to plus 5, and gets reduced to by gaining electrons from NO2 to NO, like plus 4 to plus 2. So the disproportionation reaction is a reaction in which one species is oxidized and reduced at the same time. This is going to plus 4 to plus 4, this is oxidized, and plus 4 to plus 5 is reduced. Next question, the release of nitrogen monoxide into the atmosphere causes atmospheric pollution. State and explain the effect of nitrogen monoxide gas in contact with the moist air. Nitrogen monoxide is oxidized to nitrogen dioxide, which reacts with rainwater, which reacts with moist air to form nitric acid, causes acid rain. The nitric acid made in stage 3 can then be reacted with ammonia to form ammonium nitrate. Stage 3, NH3 nitrogen dioxide, water to form nitric acid, and nitrogen monoxide. And ammonia react with nitric acid to form ammonium nitrate. Calculate the volume of nitrogen dioxide measured at room temperature and pressure required to make 40 tons of ammonium nitrate. Mole of ammonium nitrate is equal to 40 tons divided by 80 is equal to 1000 kg. 1 ton is equal to 1000. This is kg, and the mole of This is not mole of ammonium nitrate, 500. Now mole of 1:1 ratio in stage 3 HNO3 ratio ammonium nitrate 1:1, and mole of ammonium nitrate is or X. Similarly, because we have to calculate volume of nitrogen dioxide, so nitrogen dioxide is there required to make 40 tons of ammonium nitrate. How calculate the volume of nitrogen dioxide? Now nitrogen in this stage 3 moles of nitrogen dioxide react with water to form 2 moles of nitric acid. So moles of HNO3, so moles of HNO3 is equal to 500 ratio nitrogen dioxide 3 ratio 2 ratio 3 2 ratio 3, and moles of nitric acid is 500 ratio X. Now mole of nitrogen dioxide is equal to, by doing cross multiply, the moles is 750, and volume of nitrogen dioxide is 750 into 24 decimeter cube. So this is the volume of nitrogen dioxide. 750 multiplied by 24 is equal to 18,000 decimeter cube. State 1 use of ammonium nitrate used as a fertilizers. Question number 3, sucrose reacts with water to form glucose and fructose in reaction A. Reacts with water to form glucose and fructose in reaction A. This is reaction A. Suggest the name for this type of reaction. Hydrolysis, because water is used to break down this molecule to form two simple molecules. So this reaction is known as hydrolysis. Explain in detail why glucose and fructose are a pair of structural isomers. Your answer should refer specifically to those two molecules. Both have same molecular formula because 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, 6. C6. 1, 2, 3, 4. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. 1, 2, 3. 1, 2, 3, 4. 1, 2, 4, 5. 1, 2, 3, 4, 5, 6. O6. And similarly 1, 2, 3, 4, 5, 6. So both have same molecular formula and different structural formula. In this compound, this is aldehyde, this is aldehyde, and this is ketone. This is ketone. Hydroxy aldehyde and hydroxy ketone. 1, 2, 3, 4. Explain in detail why glucose and fructose are a pair of structural isomers. Both have same molecular formula but different structural formula. Same type of atoms, same type of atoms, but at different position. Like glucose has aldehyde, while fructose has ketone group. The reaction A occurs faster in the presence of an enzyme. This is reaction B. The activation energy for reaction B is plus 29 kilojoule per mole. Predict a value for the activation energy of reaction A. Okay, this is reaction B, which occurs in the presence of an enzyme, and A without the reaction A is without without the enzyme. So predict a value for the activation energy of the reaction A. So this is plus 29 kilojoule. So if enzyme without enzyme, it is around about 40 kilojoule per mole inverse. The enthalpy change of for reaction A is minus 114 kilojoule. Predict value for the reaction enthalpy change for reaction B. There is no change in enthalpy change if even if enzyme is used, so there is same enthalpy change. So the enthalpy change is minus 14 kilojoule. Sketch a labeled energy level diagram for the reaction B. Use the relevant values from C1 and C2. This is activation energy and this is enthalpy change. Minus 114 kilojoule mole inverse 1. This is enthalpy change. 1 gram of glucose C12H22O11 is completely combusted. The heat energy produced is used to increase the temperature of 250 gram 1 gram of sucrose inside a calorimeter from 25 to 40.7 degrees centigrade. These data can be used to calculate the enthalpy change of combustion of sucrose. Explain what is meant by the term enthalpy change of combustion of sucrose. 1 mole of it is enthalpy change. It is enthalpy change when 1 mole of sucrose is burnt in excess of oxygen to form carbon dioxide and water under standard conditions in their standard states. Use the data booklet to calculate the enthalpy change in kilojoule per mole for the combustion of sucrose. Assume that all of the heat energy produced is transferred to the water. Moles of sucrose is equal to 1 gram over 342. Moles are 2.924 into 10 raised per 2 minus 3. Now heat energy produced is from enthalpy change. Q is equal to mc delta T. Q is equal to 250. Specific heat capacity is 4.18 into 40.7, change in heat to 25 degrees centigrade. Q is equal to 16 joules. This is joules divided by 1000. So this is equal to 16.4065 kilojoule. Enthalpy change is equal to minus Q over N. Delta H is equal to minus 16.40 divided by 2.924 into 10 raised per 2 minus 3. This is equal to minus 5610. The answer is 5610. Question number 4. An unlabeled bottle contains a straight chain haloalkane Q. The molecular formula of Q is C5H11X, where X is a halogen, bromine, chlorine, or iodine. A test is carried out to identify the halogen present in Q. A sample of Q is added to sodium hydroxide and warmed. Dilute nitric acid is then added, followed by a few drops of aqueous silver nitrate, a cream precipitate. So creamy precipitate is obtained for silver bromide when silver nitrate is added to the solution, to this solution. So the suggests the identity because cream precipitate of silver bromide is formed. So the halogen is bromine. Write an equation to describe the formation of the creamy precipitate. Include state symbols Ag positive, aqueous, plus Br negative, aqueous, to form AgBr solid. Describe a further test which would confirm the identity of X. Add aqueous ammonia, add concentrated ammonia solution to AgBr, precipitate dissolves. The reaction Q with sodium hydroxide tend to proceed via an SN2 reaction. SN2 mechanism suggests the structural formula of the straight chain haloalkane Q. Straight chain haloalkane Q. And this is C5H11Br. Explain why the reaction tends to proceed via an SN2 mechanism rather than an SN1 reaction. Because it is primary halogenoalkane. Which are relative unstable which form relatively unstable carbocation due to the presence of only one alkyl group exerting less positive inductive effect on primary carbocation, which is unstable and exhibit SN2 reaction rather than SN1. So you only write down that it is primary haloalkane which form relatively unstable carbocation due to presence of only one alkyl group. Two different haloalkanes P and R with the molecular formula C4H9Cl are separately dissolved in ethanol and heated under reflux with sodium hydroxide. The major organic product of each of these reaction is methyl propene. Methyl propene. Name the type of reaction occurring. The type of reaction occurring is elimination reaction, because elimination of simple molecules like HCl and form methyl propene, which is the major organic product. Write an equation using molecular formula to represent the reaction occurring. Cl plus sodium hydroxide to form C4H8 NaCl plus water. Draw the skeletal formula of the methyl propane. Methyl propene. This is methyl propene. Give the name of P and R. P and R. This is 1-chloro, 2-methyl propene. Because the major product is methyl propene, so the structure is 1-chloro, 1-chloro, 2-methyl propane. The reaction sequence shows how ethene can be converted into other organic molecules. C2H4 to alcohol. This is addition reaction, addition of steam, reaction H3PO4, catalyst 60 atmospheric pressure and 300 degrees centigrade. Alcohol to aldehyde. This is oxidation. And reaction 3 is nucleophilic substitution, because reaction 3 CN is formed. Nucleophilic addition. This reaction is nucleophilic addition. And reaction 4, heat with dilute acid, CN. Reaction 4, compound WCN is hydrolyzed to form carboxylic acid. Name of mechanism, reaction 1. Reaction 1 is electrophilic addition. Name of reagent, steam, and condition H3PO4 catalyst, 60 atmospheric pressure, 300 degrees centigrade temperature. So reaction 2 is oxidation, acidified potassium dichromate or potassium manganate. Seven plus heat. 6 is reaction 6. So this is chlorine and this is ammonia. This is nucleophilic substitution. Cl is substituted by NH2 group. So this is nucleophilic substitution. And alcoholic ammonia. And condition is heat under pressure in sealed tube. In reaction 3, the organic molecules reacts with HCN and a KCN catalyst. Complete the diagram to show the mechanism of the reaction occurring include all the relevant dipoles. Partial positive, partial negative, and it's negative. This is partial. Partial positive, partial negative. So name the functional groups present in the product of reaction 3. Product of reaction 3, nitrile and alcohol. Draw the structure of the organic molecule W formed in the reaction 4. This is the reaction 4. So this is OH, skeletal formula. Yes, this is the structure of the organic molecule W formed in the reaction. This is all about of this paper. Please like the video and subscribe the channel.